Okay, so this is how it looks after the cleaning. I've removed it from the aluminum frame, so I took it out of this and just cleaned the board. This is what we have. It's probably never been this clean in its life, but now it's really easy to see what we got going on here with all of the old flux removed. I also removed the before I cleaned it, I removed certain trouble areas that I knew that probably were going to have damaged tracks, like up here around the where the driver in the finals is and such, where that 2SB 754 is. So probably will not be putting that guy back. I will put a tip 36 or the like in its place, but overall the damage to the board is not that bad. It's certainly something that can be worked with. So now I have to remove the capacitors that I know are damaged. Now, there was a couple over here. This guy, some of these polys over here, and I've got to start putting in replacements for the parts that are missing or broken that I do know about. So I'm going to go ahead and do that. I also removed this, and that was because it looked like, and this is the cap here, it looked like the lead spacing was wrong, and of course it is, because if you have a capacitor, an electrolytic like this, you can't squeeze the leads or stretch them apart. A lot of people do that. It's actually wrong. You do it in a pinch, stand it off the board or something if you want it to test something, but really it shouldn't stay that way. And you're putting stress on the seals under the cap. So wrong lead spacing on that capacitor. Certainly wasn't the original capacitor. It's also too big for the space. Capacitor upgrades are, I hate to break it to people, are essentially BS. They don't work. They don't help you in any way. So people do them, and it clearly had been done here where that was upgraded. So the next step for this guy is to go ahead and put all of the known missing components back and remove anything that's sort of sketchy, and try to power it up and see what happens. See what that's where we're going to find out what is and what is not working on this board. So stand by while I do that. Okay, so I've got my interesting project here, this 88 board. So it's the next day. It's been cleaned. I have gone through and added all of the parts that I could find that were missing. So there were these polys in here that were either broken or missing. There were a couple of caps in here that were crushed. There was a bunch of parts missing up around the AMC and ALC, which is an interesting thing. I'll have to come back to that and hypothesize why that would be. There were these coils were all deformed, so I just wound new ones and moved on. There was like this jumper, and I knew this wire was supposed to be here, and I had to figure out where this wire belonged. There's another orange wire here, but it's just connected to the ground plane, and I think it has something to do with the echo. Didn't have a 4558 in a dip, but I had one in an SO, so I just put an adapter in and put it in there. So that's what that little board is there. So other than caps, you know, putting parts back, lots of transistors. Lots of transistors were yanked. There's like one over here, this one. I think that one was gone. That one was gone. Like one up here, some down in here. There were a bunch of transistors that were pulled. So, oh yeah, and the pot. So what I did is replaced the pot, and I centered all of the controls. So everything is centered. And I've added these two wires where the chokes would normally go so I can power this board up. So, you know, this is going to be the smoke test. So all these jumpers that I have here, this is an attempt at putting the radio, turning the radio on, getting it power, and putting the radio on AM. So the radio should power up and go to and be on the mode AM. The PLL, I just tied what would normally be the second 4-bit adder. I just tied its carryout pin high, which goes to that would be bit 8. So that should be the equivalent to encode 256. So that should be right dead smack in the middle of the PLL's range. So I guess the last thing to do is to just attempt to power the thing on. Okay, so I am going to get ready to test this. So I've got my scope handy. I've got some leads soldered in here so that I can power it up. But before I get into this smoke test, I'm going to put this under here so that we can see the screen without any glare. So I've got all these jumpers to configure this board for AM receive. So this should put it into AM. It should power up. This would be where the power switch connected. This stuff sets mode and all that good stuff. And so the only thing left to do is turn it on and see what works. I've replaced every part on here that I could find that was missing. I've rewound these coils, so all these inductors are rewound. So we're all good there. We've got new inductors. I didn't have a dip 4558 op amp, but I had an SO, so I put an adapter in and stuck that guy in there. Any cap that was crushed or missing, or any other part that was missing that I could find, has been replaced. So that's basically all that there is to do, is to try to power it up and see if anything smokes, and if it doesn't, to see what does and what doesn't work. Unfortunately, with the current configuration, I can't test much. But what I'm looking for right now is power supplies. So this radio pretty much, it just has an 8-volt rail. So the thing that I'm going to work on right now, or I'm going to check right now, is does it power up? And do I get an 8-volt rail? And is that 8-volt supply reasonable? And the only other thing I can check out would be the PLL. What I've done is I've soldered a jumper to bit 8 on the PLL, so bit 8 will be high. And that basically means that we should be at encode 256. So encode 256 is about the middle of the range of this PL. It's a 512, you know, it's just 9 bits. It's 5 511, whatever, but starts at 2. But so 256 is pretty much, it's pretty close to the middle of its range. So if it's going to work, it's going to work. If it's not going to work, then you know, it's not going to work. But that's if the 8-volt supply is even working. So I guess only thing I've got to do here is turn it on. So I'm gonna grab the crocodile clips and see what happens. Gonna be ready to get this off of here in case this thing does something bad. And it's drawing a reasonable amount of current, so that's a good sign. Don't feel anything getting hot. Not even the 8 volts, so I guess see if the PLL's got its 8 volts. I'm not going to complain. So it's got its 8. The op amp's got its 8. Okay. No weird current spikes. Nothing's getting hot. Okay. Do we have reference? I'm trying to remember what it is. It's either 2 or 3. That looks like divide by 2. No, 2. That should be 5. That should be like 5.12. Yeah, that doesn't look right. Is the scope just not reading it right? I thought that was a divide by 2 pin, if that's what that is. So we got reference, but that looks weird. 2 point. It's like divide. I don't know. I've got to go look at the data sheet to remember what this is. It's been a long time since I've fooled with these. So what is lock? I'm trying to remember what lock is now. This is 9. I think it's 8. 9's that last bit. That's at bit 8. I think it's 8. So let's go ahead and look at 8. It's locked. Hello's locked. Unless it's bad. But that looks locked. See what we got here. The counter. That I think that's working. 16106. Keep in mind, I have no clarifier control. No fine and coarse is connected to this. So I'm not expecting it to be the correct frequency. I'm expecting it to be close. So 16106. So 16106. 26880, that should be 26806. That's probably right. So I think the PLL's working on this. I don't have a selector. It's not like I could go and see if it's doing the correct steps. And what I think is that divide by 2 output is definitely not looking like, it's looking strange, unless the scope's grabbing a harmonic or something, which it could be. Let me just use the counter. We just take this probe and put it over on the counter and see what the counter says it is. Oh, the counter says it's 2.56. It's weird. I gotta look at a data sheet. Am I correct in assuming that that's a divide by 2 and not a divide by 4? And I have it up over here. There is the pinout. OSC in, OSC out, divide by 2. That is interesting, is what that is. That's really interesting. That it's, because it should be 5.12. I don't know what to say about that. I think something is a little wrong there. But it's locked, and this radio doesn't use it, so even if like there was something wrong with the divide by 2 in this PLL, who cares? It doesn't use it. These don't use that. But there's something not right in here for sure. That is strange, is what that is. I have no idea what that is. That's all kinds of weirdness. I gotta remember what the pin out of this is. That is weirdness. That is... That's divided by... That is weird. That is like divided by 4. That is strange. Okay. I'm stumped by that one. I think PLL... I think that the divider in the PLL is out to lunch. But that said, nothing is still getting hot in here at all. Not even the 8 volts. So the PLL's up. The next thing to do, and I grabbed this I grabbed this little pigtail out of the bin. So I'm just going to use this to connect in and get an antenna connection to this, so I can get a signal generator on this thing now, and see if I can track a receive signal back through here, and see if at the volume where the volume control would normally connect on this, if there is anything that resembles or any receive. So I guess that's the next step here, is just to see if the thing receives, if this board is in fact receiving anything, because it should. 26806 I should have received. So I guess stand by while I prepare that particular arrangement and test. Okay. So it's a day or two after the last time I looked at this. I just wasn't feeling so hot, so I just didn't feel like bothering. But I did get to the bottom of the issues with this radio, and in checking the receive. So what I found out is it was deaf as a doorpost. There was no receive. The first issue with that was there was no receive 8 volts. So no 8 volts for the receive, nothing's going to work. So that ended up being some work was done in this area. And this is where the transmit receive switching power supplies are done. It's down here in the corner. And also things like the Roger beep. And one of the channels of this op amp is configured as a comparator. And I think that, and this isn't the first time I've actually seen something go wrong with this circuit. A lot of the problems that I've seen in the past with this circuit are sort of self-inflicted. It's because I don't think people understand how it works and what it's doing. And the first thing that I went for is the Zener diode that's in here. Because I took one look at it and was like, that's not a Zener diode. And I didn't have a 5.1 volts Zener. So, not in that form factor. So I actually stuck it in the back of the board as a, there's a, oh man, it's a like a SOD 323 or something that's back there. But the comparator and these 3 transistors that are doing this switching, it's an interesting circuit that I'd have to probably cover more in depth so that people could understand it. But basically you have this comparator and it's looking at that transmit, that PTT line, and determining whether or not that PTT line is being dragged down and outputting on the output accordingly, which then switches this bunch of transistors down here, and one of them turns on, the other one turns off. So for receive, you turn on and you have the 8 volts that passes up to the receiver, and whatever other things in here need the 8 volts and receive. And then the other one is turned on when you're transmitting, and so you have your 8 volts for your transmit stuff, and your receive 8 volts goes away. And a lot of that is steering of voltages and stuff is accomplished by all of these small signal diodes you see all over the place. These 4148 diodes that are all over these boards. You know, like the ones that would be down here if they were populated. That's all diode logic. There's a lot of it in these radios. I don't think people quite understand it. It's just the way things were done back when these were designed, because it was the simplest way to do things. So that said, it does receive now. So I got my little pigtail that I slapped on here so that I could test the receive, and it is receiving. Not that great. You know, better than I kind of expected it to, but I think there's still some issues with it, so I need to go through it with an RF probe, and that'll be for another time. But the parts that I ended up having to, you know, work out in this receiver, I did find quite a few of the ferrites were cracked. So just getting them here. So how many of these guys do I have here? So I got these ferrites, and these were all, you know, they all had one end cracked. So I replaced them, you know, from a donor. So, you know, it's just a matter of, you know, flip it over, back it out, and slide another one in there. So now that that is done, everything is adjustable, and I just gave it a quick tweak, and I got it mostly, I think, working. So it does receive, but it's not, like I said, it's not where I think it should be. But that's a matter of RF probing through here and through the receiver chain and figuring out if there's any other issues with anything and resolving those. So that will have to be for another video, as well as starting to look at the transmit side of things. But in order to really work on the receive side of things, I'm going to have to get some clarifier, you know, connect the clarifier and you know, volume control and things like that, so that I can at least have something to try out. And I will, of course, need to wire up a microphone connector, which I believe would go to these 3 pins, so that I can test transmit or work on the transmit as well. So there are several parts still missing in that section. There's some resistor and inductor, you know, there's like an L47 and an R218. So there's a resistor that's missing there, and of course the resistor had a bead on it. And there's one there, and one there. So I've got to get these resistors, but I also have to get some beads. And I don't think I have any beads, so I'm going to have to get some beads and you know, go from there. So with that said, I guess that will end this for now, and pick this up, and maybe when I do the next one on this, it will be fully functional. So that is that. Till next time, cheers.